This lesson is talking about finding fractions in simplest form using prime factors. We will talk about numbers as fractions, and we will talk about them as monomials as well. The first example here is 16/20ths. Some of us know already how we can simplify 16/20ths because we might already know the prime factor that goes into both of them, or the largest factor that goes into both of them. But what we can use is we can use prime factors to help us find exactly what it is and which number might be the most or the biggest one to use. So 16/20ths. If you look at 16, 16 can be thought of as 2 times 2 times 2 times 2. Okay? 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. On the flip side, we can look at 20 as 2 times 2 times 5. Now as we look at the combination of these two numbers, we notice that there are some common threads here. We both have a set of 2's that's common in both, and another set of 2's that are common in both. So we can take those 2's and say, well, that's 2 times 2, which is 4, which means they have a common thread of 4. So we can continue on by saying we can divide both the top and the bottom by 4 over 4. 4 over 4 is 1. Dividing by 1 doesn't change anything. It's just going to change how it looks. It's not going to change the value. So 16 divided by 4 is 4. 20 divided by 4 is 5. 4/5 then becomes our fraction in simplest form using prime factors. Now we can take a look at the next one, 35/40ths. 35/40ths might not take as long, it may be a little simpler, but again you might know what the common or a common one is in there. And for example, 35 can be separated as prime factors as 5 times 7. Both 5 and 7 are prime, so they are prime factors. 5 times 7 is 35. Looking at 40. 40 is divisible by 2. Okay, so then we have 20 remaining, and 20 is, as we set up here, was 2 times 2 times 5, so 20 is 2 times 2 times 5. You will notice then that our common one here is 5, which means we're going to divide by 5 over 5. Again, 5 over 5 is 1. Dividing by 1 does not change anything. Just changes how it looks, doesn't change the value. 35 divided by 5 is 7. 40 divided by 5 is 8, leaving us a prime factor, or a fraction in simplest form of 7/8. Now we're going to take a look at monomials. And when we look at monomials, we're going to look at the number as well as the factoring of the monomial. So if you look at the first one, we're going to look at the number part first, and we look at 21. 21 as a prime factor is 3 times 7. And then we look at the 8 of the third. 8 of the third is a times a times a. And then we can look at the bottom part. 11. 11 itself is prime, so 11 becomes there. A times it, nothing else, because there's only one a. Okay, so what do we have in common in both of these? We don't have much. Okay, we don't have much, and so we're going to actually be looking at taking out the common ones, which is just a. So we're going to divide by a over a. So taking those out, in a sense, these cancel out. Okay, we're left with 3 times 7, which will be 21. We have 2 a's left, so it would be a squared over 11. Nothing else remaining on the bottom there. Everything here is simplified. There is nothing else that we can do with this problem to simplify this fraction, so that is as simple as we can get. Second example, 6b. 6b itself is factorable. So as we look at that, we're going to take apart this 6. And 6 is factorable as 2 times 3 times RB. The denominator, 24. 24 we can say 3 times 8. 8 is not a prime factor. 8 is 2 times 4, or 2 times 2 times 2. So we have a lot of 2's here. 2 times 2 is 4, times 2 is 8, times 3 will get us our 24. And we have two b's. B times b. Find out what is common in both of those. We have a commonality of a 2, some 3's, and some b's. Okay. You can simplify those out. In a sense, they become canceled. 2's and 2's are gone. 3's and 3's are gone. B's and b's are gone. I am left with nothing at the top. But when there's nothing at the top, we actually have a 1. 1 at the top. We have 2 times 2, which is 4, and then 4 times b at the bottom. So 1 over 4b becomes our answer for this one in simplest form.